let me start recording. So good morning, everyone. Welcome to another chapter of Advance R Book Club. Thank you for being here. Today, I'll be discussing chapter 16. I think I said chapter 17 in my announcement, but I meant chapter 16, which is about trade-offs between the different object-oriented programming systems that we've learned about, S3, R6, and S4. We also learned about base types, but we're going to be talking about the differences between those latter or those former three. And before that, I just want to announce that next week we'll be taking a break, 1 week off, because I've got a scheduling conflict and also, I don't know, it's end of semester, short week. Let's take a break. We're actually at a good stopping point midway through. The next chapter will be on metaprogramming, so we're starting a new topic. So no session next week. And with that, I will just start talking. Let me share my screen. So today we will be talking, as I mentioned, about trade-offs. And so what Hadley has done in this final chapter of the object-oriented programming section of the book is gone through the different object-oriented types that we've talked about and compared them and said, kind of here's when you want to use these. So I'll be going through that. It's a shorter chapter, so we might wrap up early. But I'm hoping maybe we can have a discussion a bit at the end about the different types and what our thoughts on them are. And so with that, this chapter poses the question, that we've learned about these different types, but how do you pick which one to use? And there are trade-offs between each of them. So there isn't one right answer all the time. Hadley says if you're not sure, stick with S3. Obviously, for those of us who work in the bioconductor realm, you might want to stick with S4 instead, since that's more suited for large teams, which we'll talk about in a moment. But just in general, S3 is simple. It's widely used, and it's probably the easiest to work with, is what Hadley says. But we can compare all of them and see the pros and cons of each of them. And I'm going to take a moment because there is a big bug. I'm going to squish it. Okay, sorry about that. We'll start with S4 versus S3. So they're not too different. The underlying ideas between S4 and S3 are the same. However, S4 is stricter, more formal, and more verbose. And that strictness and formality makes it great for large teams, such as Bioconductor. The book goes into some detail about what Bioconductor is, about how many packages there are on Bioconductor, and about how Bioconductor makes good use of S4 objects, such as summarize experiments. It mentions that S4 is great when you have these complex systems of interrelated objects, as this allows to minimize code duplication. If you are smart about how you implement the methods. And it gives an example, which I won't go into, but it shows that the matrix package that the matrix package has like just a whole lot of interrelated classes, functions, and methods. And it shows a diagram, which you can check out if you're interested, of how the matrix package works. So again, S4, easy to provide a general method that works for all inputs among a large combination of interrelated objects. But the trade-off here is this requires some careful planning. You need to make sure that there's no ambiguity of your methods. And another challenge is that S4 is complicated, and the documentation for S4 is not in a single place. Instead, it's scattered throughout a combination of the R documentation, books, and websites. Hadley says there needs to be, like, someone needs to write a book on S4 in particular, but no one has written such a book yet. So that is S4 versus S3. More, the book focuses on the difference between R6 versus S3 because this is a bit bigger of a difference. You remember R6 has some unique properties. So we'll talk about that and we'll review that. So as a reminder, R6 is very different from S3 and S4 because it's based on these encapsulated objects rather than generic functions. And R6 objects have reference semantics, which means they can be modified in place, which is something you can't do or not do as easily, I guess, with S3 and S4. And these two differences have consequences for naming. You can return a value and modify an object simultaneously, and invoking a method is different in R6. You remember you say like the object and then $, and then the method. And this allows you to chain methods in a way that is kind of a alternative to piping, which we will talk about in just a second. And so we'll go through each of these in turn in more detail. So the first is naming. So since generic functions for S3 and S4 are global, all packages share a namespace, and this has consequences in terms of you have to make sure that you are using maybe a unique name, because if the name of your function is similar to other names, that the user will have to call it directly by typing the name of your package and then : the specific function they want to use. And he gives this example where you kind of have the same verb, but it means a lot of very different things. So you could maybe want to plot some data, but that's different from plotting a crime, which is different from a plot of land, and it's different from the plot of like a movie. Those are all, so the verb in all of those, I guess, sentences is plot, but it means different things. And the same thing is true in, like your ARC code. You might use the word plot to mean something completely different. And if it conflicts, if a different package uses the same function name, then your user is going to do something about that overlap, and that can cause issues or be taxing on your user. But in contrast, that's not really a problem in R6 because methods are scoped to the object. So you would have that method as part of the object. So here, you would do data $plot. And so in this case, there isn't that overlap between, the namespace that would be a problem with S3 and S4. The book also details that these issues of naming conventions can also apply to arguments. S3 generics usually have core arguments like X or .data, and they also use ... to pass on additional arguments to methods. But this has a downside. If you misspell an additional argument, it will not create an error. So that can be an issue, and R6 can solve that by allowing you to use more evocative names for your arguments in a way that you can't do with S3, or maybe shouldn't do with S3. And yeah, you can use more specific argument names with R6, which is an advantage. This also means that creating an R6 method is very cheap. I think he means kind of mentally when he uses the word cheap in this context, like in that you don't have to think so much about whether the new method you're creating is going to conflict with another method. You can just create it specifically, for that object, and the name you can give it is just, whatever you think is the best name. You don't have to worry too much about whether you're creating something that's going to conflict with other methods down the line. And in fact, R6 encourages you to create many small, very unique or specific methods. And each can do one thing and they can have an evocative name, which is a benefit to R6 over S3 and S4. And he says S3 is more expensive because you have to create a generic and you have to worry about the naming conventions. So that's the first of the three topics he talks about. So the next is the threading state. So one challenge with S3 is when you want to both return a value and modify an object. So one of the guidelines he introduced earlier was that a function should either return a value or have some kind of effect on your data, modify the object in some way, but it shouldn't do both, generally speaking. But sometimes you do want to do that. And it's best to illustrate this with an example. So he gives an example that you want to create a stack of objects with two methods for that stack. So push in this stack of objects adds a new object to the top of the stack. So I think of this as like a deck of cards. So, like if we can imagine, like we deal out and put a little stack of cards like on top of each other. And then we want to add another card to the top of the stack. That's what push does. And then pop is like to draw the card from the top, returns the value of that card, and then removes it from the stack. Push is fine because it's just adding a new object, so it's modifying an object, it's not returning a value. But the issue is that pop both needs to return a value and modify the object that it is drawing, the top of the stack from. And so looking at this in R, we can, he's written code for it. So this new stack just creates a stack. And then the push will add something to that stack, and so and then we've got pop, which will draw it, display it, and then we need to remove it. So if we make that new stack, so we've created this object S, we can see it's a stack. It doesn't have anything in it right now, but we can, using push, we can add something to it. So we've added something to the top of the stack, and then we can push again, add something else to the top of the stack. So we've got 10 and then 20, but now we want to pop. So again, we want to draw that top card, return the value, and remove it. So we run this here, but we see it doesn't return anything because it had to remove that. So if we look at S now, it still has that in there, but we now have this out, which has an item with it. And if we want to actually remove it, then we have to reassign the out and then rerun it. Now we've removed it. And so the issue here is that we had to do all these extra steps to get the pop to actually work. Like we couldn't just do it in a single function call, but we had to actually run pop, then reassign it to the original object with the card that we removed from it. And so this is a downside of S3 and S4. It's because it's trying to return a value and have a side effect, which is removing the object from the top. And we can't modify the object in S3, so we need to do two things. We need to both, return the value and then update the object in S3. This problem is known as threading state or accumulator programming, because no matter how deeply you call the pop, you still have to, reassign that modified stack object back to where it was. So reassigning it back to S. And it's much easier to do in R6. So if we look at the same thing in R6, so this is doing the same thing. So we're now this time making R6, but it's still the same thing. It's a list with, we define 3 functions for it. So push, which adds an item, adds the card to the top of our stack, pop moves the object and returns it. And then we've got a length function, which tells us how big it is. So now if we run this, create a new stack. So we're doing the same thing we did before, this time doing an R6. So if you remember, our methods are encapsulated. So we use the $sign. So if we look at S right now, we see that it's just an empty list, but we can add something to it. So we just add a value of 10. Yeah, if we call the items, we can see that there's a single item with 10 in it. And now we've got 20, but now we can run pop and we can see we both return the card that was on top of the stack. And now if we look at the items, we see that it's also removed. So in one step, we've done what took, what was it? Like it took 2 lines of codes here, but we were able to do it in a single line here. And we didn't have to reassign it to that original object the way that we did with, taking it out and then reassigning it back to S. So that's an advantage of R6. I believe the book earlier on said this is particularly useful when working with like API calls. So if you're getting data externally, I could see how you might want to return, what you're receiving externally, but also modify an object and add to that object as you're, displaying stuff that you're downloading. But I actually wanted to open the floor here and see if anyone had any experience working with R6 objects that they wanted to share their experience working with it.
My only experience is Vince using R6 objects and everyone else thinking he was crazy.
Okay.
We actually use an R6 object in BIOC check to represent the log, running log. And we have methods for that.
Okay, because there's a log running, so you're both modifying something, but it's also you want to display an output of how things are running.
Yeah, so you're adding messages to the log and printing them and formatting the messages as you go along.
Okay, so that's a cool implementation. The other example that Hadley gives is apparently scales in ggplot2 use an R6 object to store the scales because when you have data across many different, charts, but you want to use the same scale, it's easier to keep it for those independent plots, it's easier to store it as an R6 object. I didn't really understand it because I don't know, scales are always like black magic for me in ggplot2. Whenever I have to use one, I just hope it works correctly because I have been in scale hell before when working with ggplot. So but apparently that is one example where R6 is being used in the tidyverse. Cool. So that's threading state.
I was wondering.
Oh yeah.
Yeah, I was just wondering, like, so it's not good etiquette or advisable to like have S3, but then you just have maybe like an intermediate, like you like return the object in kind of like an intermediate state. You know how you modified and like had to like reassign the object in like S3? Like, could you do this in a nested function in S3 or is that like not advisable, I guess, like to modify it and then return it? Yeah, does that make sense?
Yeah, so you would say like pop S, I guess what that would look like is S pop S X, something like that. But that's not going to return what you actually get, right? That's just going to assign. Let's just try it, see what happens. Yeah, so the problem is that assigns it, but it doesn't output it. So how do you output it while still assigning it in like a single step?
Yeah, I guess it still wouldn't be like a single
Yeah,
step. It'd still have to be like some type of multiple nested function or something.
yeah. I think
Yeah.
the idea is to avoid kind of that kind of nesting.
Okay, yeah, that makes
Yeah,
sense.
yeah. That's a good question. Um, cool. So that is sorry, threading state. The final example he gives is method chaining, where you might want to use R6. So one advantage is we do have the pipe operator for S3 and S4, where you can use, you know, percentage sign, I don't know what you call it, the right caret percentage sign or bracket right caret. Uh, you can use those in S3 to make easy, make it to compose functions left to right. But you can technically do that also with R6 by default. So in this case, you can chain those. So here's an example of where you chain the pushes and the pops. You do everything in a single step. And this technique of how you chain it like this is very common in Python and JavaScript. And so the advantage here is that for people who are more used to, you know, those languages, this makes more sense to them. So it's probably easier for them to learn. And it doesn't really go into any disadvantages aside from the fact that like these methods that you're chaining have to be part of the object. So you can't chain something new into here. Like if we didn't define a mean like we couldn't chain mean into here. But yeah, that it allows you to do method chaining kind of like you were working with pipes. And that's the last bit that the book talks about. So that is the end of chapter 16. I'm going to open up the floor to, you know, discussion. Are there any questions or comments about the different object types?
There's another newer system called
Uh-oh.
S7,
Okay.
and I can post the link on. It's a project from the R consortium, so it tries to combine um, S3 and S4. That's why it's called
Okay.
S7.
Oh, because it's 3 plus 4.
Yeah.
Okay. Is anyone using it yet for anything? Or is it just like
Um,
theoretical at this point?
it's still in development, but Hadley and other people are working on it.
Okay. So the idea is that like something like a summarize experiment would just work in S7 though? Or would there have to be any updates?
I think this is a new system, so they'd have to be defined in S7.
Okay. Interesting.
I'm not sure how easy it is to convert into S7. I haven't looked at it much.
Yeah. Okay. So Hadley should add a chapter to his book soon then.
Or
Um,
Marcel should write a book on S4 and S7.
yeah, you should write the book on S4. Hadley wants you to write it, Marcel.
I'd have to ask Martin to write it for me.
Cool. Are there any other, I know there's the RC object types. Are there any other object types that that are coming down the line or anything like that? Guess not.
Cool.
Yeah. Well, I think I'm good having an early session. You know, it's a holiday weekend. Oh, there's something in chat. Oh, it's the link to S7. Okay.
Yeah.
Okay, what I linked. Yeah, perfect. Um, cool. Well, we can have an early session. That's fine by me. Thank you all so much for attending. And as I said, we're gonna take a break next week because we're between sections, but we will pick back up the week after with the introduction and big picture of meta programming, which I guess is the idea that you can write code that modifies other code, which kind of breaks my brain slightly, but I'm really excited to learn more about it. So I will talk to you all in 2 weeks, and I will get the I will get the recordings posted, and I'll email you.
Oh, thank you. Yeah, I mean, no rush at all for
No,
that. Whenever
they've
you
been
get a chance.
they've been sitting. I've got the YouTube playlist and everything ready to go. They've been sitting on my desktop, so I will do that today. Cool. Thank you all
Thanks.
so much.
Thank you, Chloe.
Yeah, have a
Thanks.
nice long weekend.
See you.
Bye.